This discussion will address effective tools for requirements and concept development. Thank you for attending, and I hope that you find this session to be beneficial to you. The SDI Tools includes a suite of tools that we found to be beneficial, have developed to be beneficial to support system engineering, design for Six Sigma, and various product development activities. The SDI Tools suite includes Triptych, Apogee as the two primary tools within this package, and then also the Reliability Test Design tool, Distribution Explorer, and the PNC Test Effectiveness Calculator. In this session, we'll be discussing tools for requirements and concept development, which will focus on the use of the Triptych tool set. The Triptych tool set includes tools for implementing failure modes and effects analysis, quality function deployment, trees, the theory of inventive problem solving, and then a set of tools also that will support decision analysis and design selection activities such as Pew, TOPSIS, and SDI. These tools are also supported by an affinity diagram tool and an analytical hierarchy process tool for prioritizing and determining the importance of various information. This tool set operates within Microsoft Excel and allows you to very easily collect information, document it, manipulate it, and make decisions as part of your product development activities. After you have loaded the SDI tools on your computer, you can open them very easily by going to the Start menu, Programs, selecting the SDI Tools 3 program group, and then you'll be presented with a list of the various functions within the SDI tools. So the Apogee tool, Distribution Explorer, we also have included an exercises folder which will allow you to access exercises used for training and then also solution sets to use for tutorial type purposes, the PNC calculator, reliability test design tool, and the Triptych tool set. In this discussion, the Triptych tool set will be the focus of our attention. In each of these tools, or the majority of the tools, they include Excel type add-in applications. Apogee, the PNC calculator, and Triptych are all operate within Excel. Standalone tools included in the package include the Distribution Explorer and Reliability Test Design tool. Once you launch the tools such as Triptych, what you'll find is that it will open within Excel as an add-in, and you'll be presented then with a menu that will allow you to select various functions for manipulating, generating templates, analyzing information, and so forth. In addition to the Triptych drop-down menu, there will be 3 toolbars that will be presented on your desktop or within the add-ins group that's in the more recent versions of Microsoft Excel. The Triptych toolbar allows you to open the worksheets, manipulate them, add information, edit them as required. A few of the tools have their own special toolbars, such as the failure modes and effects analysis toolbar, and then also the toolbar for the affinity diagram tool. So within this package, you have the complete capability to create, generate, and modify affinity diagrams, execute the analytical hierarchy process, develop QFD houses of quality, make use of the trees, theory of inventive problem solving concept, present various design alternatives from which you're trying to find a preferred selection using the Pew, TOPSIS, and SDI method, and then also create and execute a failure modes and effects analysis session also. So like we said, each tool opens up within Microsoft Excel and allows you easy method for creating information, editing information, and documenting the information for use on others on your program. The Triptych tool set mainly contains a set of 3 categories of tools. Triptych is defined as being a set of 3, primarily used in the art world to represent 3 different scenes that combined together would represent the total picture. In product development, we see Triptych as being the voice of the customer, innovation or creating alternatives, and then also selecting the best alternative or the design selection function. We use this tool set to augment the product development process to help you in understanding what the problem is you're trying to go solve, organize ideas and information you have regarding the problem you're trying to solve, and identify the primary needs and what's that will be important to getting to the preferred solution. The tool that we have in the tool set to support this is the affinity diagram tool. The next step, and you can flow information from the affinity diagram to a tool to help you prioritize needs in watts, and that is the analytical hierarchy process, or the AHP importance tool. Once we understand what the primary needs are and have those prioritized, now we're ready to start looking at how we can convert watts into hows, analyzing the relationship between these watts and hows, identify the critical requirements for this solution, and then decompose these requirements into lower levels. The quality function deployment technique really supports this application of this set of concepts very, very well. It allows you to document your watts, create the hows, assess the relationships, and then flow this information to other houses of quality to support the requirements decomposition process. Once the requirements are identified, now we can start identifying or entertaining various candidate solutions that could assist us in meeting this requirements to support the stakeholders' needs. A lot of times requirements are developed using past experience, analogous approaches, benchmarking with other technologies, and sometimes we need to use innovation techniques. So within the SDI tool set, within the Triptych tools, is a trees tool that will allow you to analyze conflicting requirements that may have been identified through your QFD process and come up with candidate solutions that could support your stakeholders' needs. Once various solutions are identified, whether they be through past experience, other alternatives, the trees method, whatever, the next step is to try to determine which is the best solution for this particular application. So in this case, what we need to do is identify what are the criteria for making this selection, assess the various alternatives against the criteria, and then hopefully come up with a rank ordering of the alternatives to see which one would be the preferred approach. So to support this, we've included a Pew tool, which is a qualitative decision analysis technique, the TOPSIS tool, which is more of a quantitative goal-based type technique, and then the SDI method for doing design selection, which leverages from multiple attribute value analysis techniques, which allows you to assess alternatives with respect to their design specifications. Once the preferred alternative or alternatives have been identified, the next step may be to identify risk that could be present within the development process, in the product itself, and the processes used to manufacture it. So in this case, we can then extend the information to start developing your failure modes and effects analysis for either products or processes and help in this early risk identification. So in this suite of tools, which is identified in this diagram, each tool can be used individually as a standalone tool, or information can be transferred from one tool to the other as represented by the solid lines within this diagram. So hopefully through this set of tools, you have techniques available to you to help you make some early decisions within your product development processes. Let's go through a step-by-step method of basically what we need to do as part of product development and how these tools will support that process. The first step, as we've discussed, is organizing the stakeholder information. From this information, we can prioritize the information to find out which areas are the most important, which may be of lesser importance to your various stakeholders. Then, with this prioritized set of information, we can start transitioning from the stakeholders' needs into the requirements that the development team will use to produce this particular product. As part of these requirements, often we find out that there are conflicting requirements for which we need to come up with innovative solutions. And when we have various solutions available to us or various alternatives, then the next step is to select the best alternative to satisfy the stakeholders' needs. Once this information is developed, then this is the proper time to start identifying and managing the various risks that may be present within the product design itself or within the processes that we use to produce it. So how did these various steps relate to the SDI tools and the tools that were within the Triptych package? To organize stakeholder information, the tool that we focused on is the use of affinity diagrams. The affinity diagram tool allows you to define a problem statement, which is of interest to this aspect of the project or the product that you're working on. Identify a set of ideas that could be related to the problem statement, and these are collected in the yellow boxes, which are identified as the just brief descriptions of ideas that may be important to various stakeholders. And then once we've identified individual ideas, we can start grouping them into groups that you identify as shown in the green boxes in this particular screenshot. So once this information is collected within Excel worksheet using these icons or these little areas for ideas and groups, you can then rearrange the information, put it within the various groups, and have an organized set of information that helps us understand what it is our stakeholders need to have addressed in this product or process development activity. Then, by identifying key information, typically the groups within this affinity diagram, the next step may be to determine what is the prioritization or the importance of the individual items identified in the groups or within the ideas themselves. So the information can be transferred directly into an analytical hierarchy process tool that allows you to perform pairwise comparisons of between the various items within this evaluation, assess the relationship of those comparisons, of those pairwise comparisons, and then automatically a scaled importance is produced for you to give you an indication of the relative importance of each one of these items, each one of these groups or ideas to your particular stakeholders. Now that we have a set of prioritized needs or a prioritized set of information from our stakeholders, we can start transitioning these needs into requirements. So using the quality function deployment tool that's available within the Triptych tool set, you can automatically transfer the information from the AHP along with the scaled importance into the QFD diagram. So this information would be documented as the watts along with the importances that were collected from before. Now we can work with our engineering teams and product development and process teams to identify the hows that will support the achievement of the various stakeholder watts. Once the hows are easily documented within the QFD, then we can start addressing the importance on a high, medium, or low importance basis, collect this information of relationships between how we plan to solve the problem versus what is desired by the stakeholders, and then automatically technical weights, the relative importances of the hows are also identified for us so we can see which requirements may be critical to satisfying the stakeholders' needs. Once the first house of quality is developed, then very easily we can transfer this information into subsequent houses of qualities. So hows from one house of quality can be transferred to watts in a new house of quality, along with the technical weights that describe or define their importances, and then the next level, what hows can easily be developed. So this process can be continued within an Excel environment using individual worksheets for each house of quality, each AHP, each affinity diagram, and basically collect the information for easy use and reference by others. The next step in our process is to start identifying solutions for conflicting requirements. The technique we've included here is the theories of inventive problem-solving technique. In the SDI Tools, what you can do is open a tree session, which will allow you to generate basically a blank worksheet where you can collect information that's developed using the trees process. The trees process is facilitated by this template that allows you to define what the contradiction is or the problem is you're trying to solve, identify the improving and degraded features that are presented within this design problem or design contradiction, and then evaluate the various design parameters and innovative solutions that can be used to come up with a solution to this set of conflicting requirements. Once you've captured or identified this information, then you can enter in your idea that would relate to your particular problem of how this information has led you to a candidate solution or a candidate approach for overcoming the conflicting requirements. And then by clicking the Save button, the information is transferred into your tree session worksheet. So here you can collect a set of information, various ideas related to overcoming various conflicting requirements that you may have identified, and you can use this for later reference in your development process. Once various alternatives are identified, the next step is to determine which alternative is the best solution. So from the AHP tool, which can be used to prioritize various criteria that would be used as part of your design selection or alternative selection, that information can be transferred directly into any one of the three design selection tools. Pew for doing a comparison with an existing or datum condition, a qualitative type evaluation. TOPSIS, which is a goal-based quantitative technique where now you can enter in numerical information regarding each design option as how it performs with respect to your given criteria. Or you can use the SDI method, which is a multiple attribute value analysis technique, which allows you to assess your options versus your criteria with respect to the requirements that they must meet. So in this case, we can find solutions that best satisfy the design specifications and will allow us to hopefully obtain a producible result. Once we have identified our preferred option that must meet certain requirements, and we're ready to start the detailed design, this is a good time to start looking at various risks that could be present if things are not done correctly in the design or in the processes for producing this particular product. So this is the opportunity to use failure modes and effects analysis. A lot of times an FMEA approach will start from scratch. Start with a blank worksheet and you'll just start creating information based on effects, failure modes, occurrences, various other conditions related to risk in your program. In the SDI tools, you can actually leverage from the AHP, the design selection of the QFD tools, and actually transfer information directly from, say, the QFD into the FMEA tool. So a lot of times your WATs are the various error modes, risk conditions of printing in your product. The risk is not satisfying what the stakeholder wants, and the effects that could lead to that could be your basic how. So you can transfer this information directly from the QFD into the FMEA, use this as a starting point for your FMEA process, and then populate the other information that's needed to identify the occurrence, the severity, and the detectability, along with creating the RPN score for each one of these effects that have been identified. So what we view on this worksheet is really on this slide is a collection of individual worksheets that are developed within an Excel workbook to facilitate your product development process. So in the Triptych tools, which are supported by a set of toolbars, which could be either standalone toolbars in some versions of Excel or within the add-in ribbon within the 2007-2010 version of Excel. You use these toolbars to basically select which worksheet you want to create, Affinity, AHP, FMEA, QFD. You can also then develop worksheets for your design selection or for your innovation techniques. Each worksheet is a standalone Excel worksheet, provides a very simple user interface, and also then allows you to save this information in an Excel worksheet for use at others that may or may not have the SDI tools. With each one of the templates, there are toolbar functions for adding or deleting rows of columns of the various templates to allow you to enter your information. We allow various techniques for cell and font coloring and formatting. You can add comments and hyperlinks to various sets of information within the tools. A lot of the numerical results are automatically calculated for you, and you can format them the numerical format of those results. In the QFD, primarily, we have a built-in check feature that will go and perform various sanity tests to confirm that you have included information that's needed to go to the next step of the process, identify where information might have been omitted, and allow you to go back then to update and edit the worksheet as needed to make it correct. We've included features to allow you to edit your worksheets and flow down information from one tool to another, such as the flow down of information from the affinity diagram tool to the AHP tool, or from the affinity diagram tool into a QFD matrix. Or you can take information from AHP and move it into one of the design selection tools. Pew, TOPSs are the SDI features. So everywhere are tools. For everywhere that there was a capability or seemed like a good option to allow you to use the information in the next step of the process, we've tried to include automatic functions to allow you to select information and then transition that to the next tool. So all in all, we found the tools to be very easy to use. The learning curve is very short. Basically, if you can operate Excel, open it, start working with the toolbars, you can start creating these templates to create information for use in your design and product development processes. So in summary, the SDI tools, the Triptych tools, provides methods for collecting and documenting information that you can start early in the product development process. You can very easily prioritize needs, requirements, criteria, and other information. You can translate this needs into requirements by flowing down the requirements to lower levels using the QFD technique. You can analyze conflicting requirements to identify potential solutions utilizing the trees method, the theory of inventive problem solving. Very easy techniques for evaluating design alternatives. So using qualitative methods such as Pew or quantitative methods such as TOPSs or the SDI multi-attribute value analysis method, you can use data or information in various formats to determine which is the best solution to satisfy your set of criteria. And then we can start the assessment and management of risk very early in the development process utilizing the failure modes and effects analysis techniques. So we found these tools to be very beneficial to a variety of companies and a variety of industries for various product and process development activities. So whether you're pursuing design for Six Sigma, you're using tools to enhance your systems engineering activities, or just want to have better ways of enhancing your product development type activities, we found the Triptych tools to be very beneficial for these applications. Very effectively organizes information, promotes information sharing to the easy transfer and interchange of Excel worksheets, really gives you an opportunity to enhance the productivity by using some established and proven methods that have been around for many, many years, but puts these in a package to make them very accessible for decision making and documentation and information collection. So we found the techniques can be applied at all levels of a system, a product, or process development, whether you're working at the top level of the system, the subsystems, lower level assemblies, components, or processes. I think you can find a way to use the SDI tools, the Triptych tools, and for those approaches. So I want to thank you for attending in this session. If you have any questions, feel free to contact me. I've provided my email address and my phone numbers here. If you want to give the SDI tools a try, you can go to www.stat-design.com, click on one of the links on the website to download the tools, install the tools, and on the first installation you'll have a 7-day trial to evaluate the tools, a full version of the tools for your applications. So I hope you found this to be beneficial, and I hope to hear from you with your questions, comments, and also ideas for applying the SDI tools. Thank you very much.